Here we go. All right, so today we're talking about imaginary numbers. Do you guys remember back in Algebra 1 when you had like the square root of negative number and they told you to write the answer was no solution? Well, now you're in Algebra 2 and there is a solution. There is something called imaginary numbers. Okay, so you'll actually find that sometimes in Algebra 2 they'll ask you for the real solution. If they want a real solution, that means they don't want imaginary numbers. Okay? But we're going to show you how to work with imaginary numbers. It is not that difficult. It's just something new. Okay. So, question is, what is the square root of negative 9? Well, the answer to that is that it is 3i. Okay? Now I'm going to show you how this works. When you're dealing with a negative under a square root, anytime you have a negative number under a square root, you take the negative out and it becomes I. Okay? That's it. So you're basically doing the problem exactly as you normally would, but that negative becomes an I and then you work out the rest of the problem. So what do you think the answer to example 1 is going to be? 9i, exactly. Okay? Now, where it becomes just, and this is two things you have to remember when we're dealing with i's. The first thing is the square root of a negative is I. Anytime you square I, it is negative 1. I squared is negative 1. Those are two things you have to remember. As long as you remember that, you're going to get all the answers correct. So, on number 2, when we're doing number 2 here, we're going through and squaring these. What is 3 squared? 9. I just told you that when you square I, what is I squared? Negative 1. And so 9 times negative 1 is? So that answer is negative 9. So when we go to example 3, what do you think our answer is going to be? That rhymes. Close. Negative 24 is correct. Because 8 times 3 is 24. I times I is I squared, but we learned that I squared is what? Negative 1. So 24 times negative 1 is negative 24. Now, on number 4, you need to work, am I going too fast? Okay. You need to work these problems a little separately. Okay, so first of all, whenever you have a negative under a root, you want to pull that negative out and it becomes a I. So I'm going to change this problem here just a little bit, and I'm going to have I root 5 times, I'm going to bring out the negative, which is I, and then I have I root 20. Are we okay with that? Yes? Okay. Now, when we're multiplying, just like we did yesterday, I times I makes what? I squared, which is, some of you already said, negative 1. We're just going to leave it like this for a minute. And then remember, when we're multiplying roots, we do outsides with outsides and insides with insides. So I'm just going to write this as 5 times 20 because we're going to end up breaking it down, right? And then what does 20 break down to be? 5 and 4, and what does 4 break down to be? 2 and 2. So I have a pair of 2's, and I have a pair of 5's. And when I bring all of that out, we end up with 10i squared. But what is 10i squared? Negative 10, because we have 10 times negative 1, which is negative 10.
To break it down inside the fraction, or if like 25 multiplied equal an even number, just like take the root?
You can. So yeah, just remember that the roots go with roots and outsides go with outsides, and however you do it, there's multiple ways to get the same answer. So you're okay either way. And any other questions here so far before we move on? All right. Okay. So 5, I'm going to give you about 30 seconds to try it on your own. And when you get to the answer, you can show me, and I'll walk around here and see if you got it right. Perfect. Not perfect. Nope. The negative under the square root. The negative, when it comes out, becomes what? It becomes I. Be careful. It's not -1 unless there's an I squared. Okay? So that means I have 4I root 36. How does 36 break down? Okay, and there's nothing left over. So that means all I'm doing is multiplying 6 times 4I, which makes 24I. Some of you wrote that as -24. So be careful. Know that the negative under the root becomes I when you pull it out. Well, that's what we're doing it right now. That's like, this is like you can have -1 times 36. So we just need to remember that you can just think of it as a negative or a -1. Okay? All right. Now, number 6. This is where it gets a little bit more tricky. Are we ready to pay attention? This is where it gets more tricky. Okay, Jet? Gur? Okay. Do you want to ask me a question about 5 or are we good? Because it's not I squared. So I squared is -1, but when you just have a negative under a root, when you pull it out, it's I. Okay, so you need 2 I's in order to make it a -1. Okay, so do you remember yesterday how I said when you have a root and a root, if you can reduce them, you can? So can 15 and 60 reduce? Yes. How many times does 15 go into 60? Good. So right now I have the square root of 4 over, this negative can't be moved up, okay? So this is over the square root of -1 right now, which is really what? I. Very good. So on the bottom I have I, and then what is the square root of 4? 2. Okay, I'm going to stop here and make sure everybody is okay with what we have so far. So, since the root 60 and the root 15, since they're both under roots, you can reduce them. Okay? So, it's the same thing as like having the square root of 60 over -15, but you have to keep that negative in the denominator because of how it's written here. But so 15 goes into 64 times. So that's how I have the root 4 over -root 1. Are we okay there? Yeah. But since this negative's on the bottom, I can't bring that to the top. Okay? It's there. Yes?
Alright, so on number 5, you had a -36 and you brought it out. Why would you bring out the -15?
You mean the -1? Yes, that's totally fine. You could do that first. You could bring this negative out, and we could have written this as I root 15 over root 60, and then you could reduce that. 15 goes into 64 times, and so you get root 4 over I again. Okay, so notice that you can get the same answer doing it a lot of different ways. Okay, so are we all good with 2 over I now? No, this is not the answer. So I just want to make sure that you guys are okay with 2 over I before I go further. So do you remember how yesterday, how I said you can't have a root in the denominator? Yeah. When you have an I in the denominator, it's like having a root in the denominator because I really represents the square root of -1, right? Yeah. So what's the only way to get rid of that I? Exactly. You would multiply by I because we know that I squared then makes what? I squared makes -1. So if I multiply the top and the bottom by I, on the top I get what? 2I, and on the bottom I get I squared, which is -1. And what is 2I over -1? -2I. So -2I ends up being my answer. So just like we can't have a root in the denominator, you also cannot have a I in the denominator. So I'm going to do it again right here, okay, just to make sure we're all clear. So I'm going to do the same kind of process. So here I have I in the denominator. The only way to get rid of I in the denominator is to multiply by another I, because if you have I squared, it makes -1. So, but whatever we do to the bottom, we also have to do to the top, okay? So in the denominator, I get I squared, and on the top, I have 2I. But the whole purpose was to get an I squared because we know that I squared equals negative 1. And then I have 2i on top, and then when you reduce that, you get negative 2i. Questions? Okay, so let's go to number 7 and see if we can figure this one out, because now we're kind of putting two thoughts here together. I would always try to reduce first if you can, because it just makes your life a little simpler. So is there anything that can reduce first on number 7? Good. So let's do that. 2 cancels out and goes into 18 how many times? So right now I have 9 over I root 6. But what can I not have in the denominator? A root or an I. So how am I going to get rid of the I and the root 6? Exactly. Very good. You're going to multiply by I root 6. This one does not have a conjugate because there's no pluses or minuses, right? It's only when you have pluses and minuses we have to do the opposite. So all I'm doing is multiplying by I root 6 to the top and the bottom. So on the bottom you have your pair of 6's, right? So 6 and 6, that makes a pair. And so we end up getting 6. And I is I squared, which is negative 1. And if you want to skip that I squared step, you can. So that means on the denominator I end up having what? Negative 6. On the top I have what? 9i root 6. And can I reduce there at all?
Oh yeah, the 9.
Good. And these are both outside of the root, so I can reduce these. So this 3 goes into both of them, right? 9 goes into 3 times, and 6. Good. So we end up getting 3i root 6 over negative 2. And that's your answer. Questions? Okay, 8. See how this squares right here with these parentheses? You always want to get rid of your parentheses first, if you can. Okay, so when you square this negative, what does it become? What's a negative times a negative? Positive. So we're taking care of the parentheses before I do the root. Okay, so I end up just getting a positive 17 squared, and you could multiply 17 squared if you want to, but we really don't want to because we're going to end up taking the 17 out, right? So this answer ends up becoming what? 17. Okay, now on this, do you see how the root 17 is inside the parentheses and the square is out? So we have to simplify in our parentheses first here. So what would I do with that negative in this one? You take out this negative, and you're going to get I root 17. And then we square it. So when we square it here, what is I squared? Negative 1. And what is root 17 squared? 17. So I end up getting negative 17. So those answers are different. So you always need to simplify your parentheses first and like work your way out.
Wait, why didn't we have a negative on 8?
Because you squared, we took care of this parenthesis first, so we squared the negative, which made it a positive. Yes, okay. So I'm going to go down here to the bottom real quick so I can hopefully get through this in 15 minutes. So here we pull out the negative and it becomes what? I root 3. Here we pull out the negative and we get I root 27. Can I break down 27? Yes, we get 9 and 3, and 9 is 3 and 3. So I have a pair of 3's with the 3 left over. So that means I have I root 3 plus 3I root 3. This I root 3 is really a 1I root 3, and you can add those together since the roots and everything is the same, so we end up with 4I root 3 as our answer.